Let's look at some other examples, but let's recall what the mean for a binomial random variable is. The mean was n, the number of trials, times p, the probability of success. And the standard deviation was the square root of n, the number of trials, times p, the probability of success, times q, the probability of failure. Okay? So let's look at a surgery example. A doctor tells you that 80% of the time a certain type of surgery is successful. Find the mean and standard deviation for the number of successful surgeries out of 10. So let's say x is the number of successful surgeries out of 10, the number of successful surgeries out of 10, out of 10. N would be equal to 10, and P, the probability of success, at 80%, that means the same as 0.80. Then Q would be 1 minus P, or 0.2. So the mean would be N times P, or 10 times 0.8, or 8 successful surgeries. And the standard deviation would be the square root of 10 times 0.8 times 0.2, and that is equal to 1.26. So the mean is equal to 8 successful surgeries, and the standard deviation is equal to 1.26 surgeries. The next question is, when 10 surgeries are performed, what number of successful surgeries would be usual? So it would be the mean plus two standard deviations, so it's 8 plus 2 times 1.26, which is equal to 10.52. And then the mean minus 2 standard deviations would be 8 minus 2 times 1.26, and that's equal to 5.48 surgeries. So between 5.48 and 10.52 would be usual number of successful surgeries out of 10. Would it be unusual to have only 3 successful surgeries out of 10? Yes, because 3 is less than 5.48, so it would be, yes, it would be unusual. And would it be unusual to have 10 successful surgeries out of 10? No, it would not be, because that's within, well, 10 is less than 10.52, so it would not be considered unusual. The next example is about guessing correct answers on a multiple choice test. Find the expected number of correct guesses on the 20-question multiple choice quiz, where each question has 1 correct answer out of 4, A, B, C, and D, provided, and a student is randomly guessing on each quiz. So X would be the number of correct guesses, number of correct guesses, out of 20, out of 20. And N would be equal to 20, since there are 20 questions. And the probability of success would be 0.25, since there are 4 questions, so yes, 1/4. And so expected mean would then be N times P, or 20 times 0.25, 20 times 0.25, which is equal to 5. And the standard deviation would be the square root of N times P, 20 times 0.25 times 0.75, and that's equal to 1.94 for the standard deviation. So then the next question is, what is a usual and unusually high number of correct answers? Well, the usual would be between the mean plus 2 times the standard deviation, 2 sigma. So in other words, would be between 5 plus 2 times 1.94, which is equal to 8.88. And then the mean minus 2 times the standard deviation would be 5 minus 2 times 1.94, and that's equal to 1.12. So between 1.12 and 8.88 would be the usual number of correct guesses out of 20 questions. Would it be unusual to guess 14 correct answers out of 20? By the way, that would be passing grade of 70%. Well, guessing 14 out of 20 would be way more than 8.88, so there would be, yes, that would be very unusual to guess your way to success in this case here. That would be considered highly unusual. Here's another surgery example. The doctor tells you that 80% of the time a certain type of surgery is successful. If this surgery is performed 7 times, find the probability exactly 6 surgeries will be successful. So the probability of exactly 6 successful surgeries means that 6 successes out of 7 times the probability of success is 0.8 to the 6th power, and then the complement of 0.8 is 0.2, and 7 minus 6 is 1 to the 1st power. Now, what is 6 successes out of 7 trials? Well, it's 7 factorial divided by 7 minus 6 factorial times 6 factorial. So 7 factorial is 7 times 6 factorial. And in the denominator we have 7 minus 6 is 1 factorial, which is 1, divided by 6 factorial. So we can cancel 6 factorials, so that is equal to 7. So then that's 7 times and 0.8 to the 6th power, 0.8 to the 6th power, times 0.2 to the 1st power is equal to 0.3670. So that's a probability of 6 out of 7 surgeries will be successful. When it comes to questions like, if this surgery is performed 7 times, find the probability at least 5 surgeries will be successful. Of course, that means the probability of at least 5. That would be the probability that x is greater than or equal to 5. So in other words, would be the probability of x equal to 5, plus the probability of x equal to 6, and the probability that there will be 7 successful surgeries. And that's very awkward to do, a lot of calculations. So it's really better to use technology for that, and you can do the online calculators for binomial probabilities, or you can use StatCrunch. And it tells you here the directions for how to use StatCrunch in Canvas and in MyLab rather. And so when you do this correctly, the answer will be 0.8520. Or you can use your TI-84. So in other words, there's a lot of technology. Similarly, if the surgery is performed 7 times, find the probability 4 or less surgeries will be successful. So 4 or less means the probability that x will be less than or equal to 4. And by computing that correctly, either technology or doing it longhand, that turns out to be 0.1481. So about 15%, roughly speaking. The next example deals with majors in college. A survey found that approximately 37% of college students have changed their major at least once. In a sample of 30 college students, find the probability that exactly 10 of them have changed their major. So, X would be the number of students who have changed major, number of students who have changed major, who have changed major. So X is binomially distributed with n equal to 30 and p equals to 0.37. And then, of course, Q would be equal to 0.63. And so then our formula looks like this. The probability that exactly 10 have changed major would be equal to all possible arrangements where you have 10 successes out of 30 times 0.37 to the x power, in other words, to the 10th power, times 0.63 to the 30 minus 10, or 20th power. And then when you calculate this correctly, your answer will be 0.1402. Okay. And again, you can use technology, which is probably a good idea because this number is a little bit difficult to compute if you don't know exactly what you're doing with the factorials, because this will look like 30 factorial divided by 30 minus 10 factorial times 10 factorial, or 30 factorial divided by 20 factorial times 10 factorial. And those numbers are getting pretty large. There's some shortcuts available, but as you can see, to do that by hand, it's really quite challenging, or can be quite challenging. So using technology, using online calculators for binomial distribution makes life a lot easier, or again, use your TI-84 or other statistics calculator, or StatCrunch in MyLab. The last part of the problem asks if a sample of 30 college students, or any sample of 30 college students, find the probability that less than 10 of them have changed their major. So here, X is binomially distributed with n equals 30 and p equals 0.37. So then the probability of that x or less than 10, change the major, less than 10 would be p of x less than 10. And if you do that correctly, using, again, probably technology, the answer is 0.2765. Next is an example of medication. And here a doctor tells you that 78% of patients improve with a new medication. If this medication is given to 10 people, find the probability exactly 6 of them improve. Set up the binomial formula by hand. So n is equal to 10. P is equal to 0.78. And Q would be equal to 0.22, 1 minus 0.78. So then the formula that exactly 6 of them will improve, so a probability of 6, would be equal to the 6 successes of 10 trials, and then we raise P, 0.78, to the 6th power, the number of successes, and Q, 0.22 to the number of failures, to the n minus x, or 4th power, and this will equal, if done correctly, 0.1108. So whether do it by hand or use technology, you'll find out, P of 10 is equal to 0.1108. The next question is about if this medication is given to 10 people, find the probability that less than 4 of them improve. So here we are asking for P of less than 4, or P of x less than 4. Again, using technology, which would be the reasonable thing to do, would equal 0.0016. And similarly, if the medication is given to 10 people, find the probability at least 6 of them improve. So at least 6. P of at least 6. So it would be P of x greater than or equal to 6. And again, using technology, that turns out to be 0.9521. So the last question is, if this medication is given to 10 people, find the probability between 5 and 8 of them will improve. So between 5 and 8, that means the probability of x less or greater than or equal to 5, less than or equal to 8. And again, if you do that properly with technology, it's 0.6711. And again, if you don't have a calculator who does that, there are online calculators that will give you the same results. The last example deals with Twitter again. When an adult is randomly selected, there's a 0.85% probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 or 5 randomly selected adults know of Twitter. So x, our random variable, would be the number of people who know Twitter, number of people who know Twitter. And in this case, of course, n is equal to 5, since there are 5 randomly selected people. And the probability of success is 0.85, so p is 0.85. And then q would be 0.15, 1 minus 0.85. So the probability of exactly 3, x equals 3, we set up the formula p of exactly 3 would be the 3 successes out of 5 possibilities, and then the probability of success is 0.85. We raise that to the x power, or to the third power, and then the failure, 0.15, q, to the n minus x, or 5 minus 3, so it'd be to the second power, and this is equal to 0.1382. And when you use technology, you get exactly the same answer, 0.1382. The next question is, if we select 10 adults, or find the probability all 10 of them know what Twitter is. So here, it's simply n equals 10, and p equals 0.85. So that's simply the probability of x equals 10, is simply 0.85 to the 10th power, and that's equal to 0.1969. And then the last question is, if we select 40 people, find the probability more than half of them know what Twitter is. So in this case, of course, n equals 40. The probability remains at 0.85. And so the question, more than half, more than half, would be the probability of x greater than 20. And again, use technology for that. And when you do that, you find that probability is 0.9999979. So that's a probability that more than half know Twitter. This is the end of section 5.3.